Good day, my amiable viewers. You are welcome back to channel. As you already know, my name still remains Israel Boy. Last time we talked about Graham's law and did the calculation on it. That was the part one part of it. Today we are going to continue the calculations, which is the part two of it, and let's get started. Graham's law. Part two. Now let's use the calculation to trace our point. Example: if 465 cm cube of sulfur oxide can diffuse through a porous partition in 30 seconds, how long will 620 cm cube of H2S take to diffuse through the same partition? We are giving hydrogen equals on the molecular masses or atomic masses 32, and oxygen is 16. So this is the question. He said if 465 cm cube of sulfur oxide can diffuse through a porous partition in 30 seconds, how long will it take 620 cm cube of hydrogen sulfide to diffuse through the same partition? We want to carry out this. Let's start with solution. 45 cube of SO2 can diffuse. So let's say let the rate of diffusion of SO2 equals ROSO2 equals ROSO2, and the rate of diffusion of H2S equals ROH2S. Good. But we know that rate equals volume over time, just like we did the other class. So you have ROSO2 equals volume over time. Similarly, ROH2S equals volume over time. Good. Say 465 cm cube of sulfur oxide can diffuse through a porous, so the volume here 465 over a porous partition in 30 seconds over 30. Similarly, the volume here, how will it take 620? 620 over time. That's what we are looking for, over time. Let's call the time x better. We now say ROSO2 over ROH2S equals volume over time over volume over time. 465 over 30, everything over 620 over x. This gives us 465 over 30 times x over 620. You see it? Then it now becomes 465x over 30 times 620. Let's see. $30 times 620 gives you 18,600. 18,600. 18,600. So that's what we have. X. Let's erase the top layer, the top part of it. I will clean it as far as this. Remember, they said how long will 620 cm cube of H2S? So we use relationship between relative, because we know the relative molecular mass. They give us this as a guide. We now say rho m H2S over, okay, let's just say rho SO2 over rho H2S is equal, this rate is equal to square root of relative molecular mass of H2S over relative molecular mass of SO2. So, and we already know that rho SO2 over H2S is 465x over 18,600. This one gives you relative molecular mass of H2S is 2. No, hydrogen is 1. 1 times 2 plus 32 over 32 plus 16 times 2. This one gives square root of 34 over 32 times 32 plus 32. It gives square root of 34 over 64. So you have, so we can delete the lower layer now. So you have 465x over 18,600 equals square root of 34 over 64. We can reduce it by dividing through by 2. We divide this by 2, becomes square root of 17 over 32. So instead of wasting time, let's just square both sides. This one becomes 465x over 18,600. This square and this square too gives you 17 over 32. If you square this, before you square, you can have a 465 s square equals 17 times 18,600 square over 32. Let's see what this one gives us first. Become 465 square s times s square equals, let's see what that one gives us. 18,600 square. We give that times 17 times 17 divided by 32. Okay. We have a value. The value we are going to have is 183 79 1250 1250. So you now see s square is equals to 183 7591250. Over 465 square. So let's delete the top layer. Whichever method you can do your evaluation is acceptable. Any way you can do your evaluation is also correct. So you have the value you have there, divide by 465 square. 465 square give you 850. So you now have 850. So x will now be square root of 850. Give you square root, give you 29.15. 29.15 seconds. Ordinary 29 if you like. So this is a very simple method of carrying out or doing calculation in Graham's law. Thank you. Please subscribe.